I think we have a good crowd here. We can go ahead and get started. I was going to wait until 05, but so I'm
I
going to
don't know.
take
I know
back.
some of these people, and I'm not going to say it's a good crowd.
So I'm just going to take over the screen for a second and I'll give it back to you, Johnny.
No problem.
All right. Um,
Do I stop sharing? Is that...
I think I can take back control. Here we go. Yeah, welcome everybody to Planet Cassandra Global Meetup. We have Johnny and Patrick today. Just want to remind everybody that we are moving to Luma. So if you can, just go to Luma/Cassandra and subscribe to the calendar. Um, Luma is probably years ahead of what Meetup is doing these days. Uh, the second thing that I wanted to bring to you guys is that if you want to really be the next contributor or committer and you're not sure where to start, some of the best places to start is to just show us what you're working on. So you don't have to be masters like Patrick and Johnny. You can just be starting out and say, hey, I have something to show. Join the ASF Slack. That would be the best place to just join the community. There's a little bit of a, I don't know, rigmarole of getting in. But once you're in the ASF Slack, we can get you, slated for an upcoming talk, maybe in August or September. And another way to contribute is, we're revamping the Planet Cassandra website. If you're making code, if you're writing articles, we'd love to get you up here and into our catalog of knowledge. Right now, it's almost ready, so we'll be publishing it by the next Planet Cassandra. This will be live. If you have any ideas, drop them in the chat or direct message me. And with that, I'm going to hand it over to Johnny and Patrick. I've known Johnny for a little while. I've known Patrick for a little while. I know that they know a lot more than I know about Cassandra because they've been doing it for much longer. But what excites me about the topic today is I love using Claude and I love using AI. So I'm just like looking forward to seeing how these masters of Cassandra are using it. So with that, I'm going to hand it over to Johnny.
Cool. Cheers, Rahul. Thanks very much. Let me just, can you see my screen all right?
Yes, sir.
Brilliant. Okay, well, yeah, thanks, Rahul, for organizing all this. Much appreciated. So yeah, as you're saying, today's talk is about AI assisted Cassandra, and also because my company Axonops, we also do Kafka. It's the same and Kafka operations. And the strapline there is stop waking your engineers at 3 a.m., or to be precise, stop waking me at 3 a.m. and use the AI instead. Um, just to briefly introduce ourselves, Patrick, do you want to introduce yourself, or should everybody already know you?
I never make an assumption. So hi, I'm Patrick. I've been with the Cassandra project for quite a long time, since early days, like 2011, 2012. But I spent a lot of time at DataStax, which is now part of IBM, which I am not a part of. I started my own consulting company this year, and yeah, still really involved in Cassandra projects. As a matter of fact, I've been probably more involved in the past year than I have been for a while. So this is great.
Cool. Yeah, Johnny Miller. I'm one of the founders of Axonops. We're a operational tooling company. We build tooling for Apache Cassandra, Apache Kafka, and other technologies coming in the pipeline. We very much focused on data technologies. We go very deep, and we provide all of the kind of observability and management tooling that you need to look after the tech we support. Yeah, my experience with Cassandra, I actually worked with Patrick at DataStax many years ago. Actually, quite a few years ago now. I think it's over 10 years now, it's showing our age. But yeah, I've been using Cassandra for quite a while. First went into production with zero point 0.6 with my colleague Hayato Shimizu, who's one of the other founders at Axonops. So yeah, so a long time user. Don't regret it. Still loving it. Okay, so what we're looking to cover in the session today, and please stop, ask questions, interrupt. Don't be worried. We're here to kind of share our experience or knowledge around that. So really, start to finish, it's about AI ops in the context of Cassandra Kafka. What does it mean? How have we done this, and actually give you some live demos of the tooling. We'll start with the problem statement, if you will, and then dig into what my company's my team's experience has been around what are the real foundations for building something to properly understand Cassandra and Kafka and give you the kind of ability to act on that through that one kind of control plane. I'll dive in and give a live demo of the ActionOps tool and the AI and the various features in there, and then I'll hand over to Patrick and he'll talk about his stuff. Patrick, or should I just wait?
Well, yeah, I have I'll be talking about EasyDB Lab mostly, but around what I've been doing with SQLite. There's only one L in SQLite, by the way. I should have caught that. Yeah.
Sorry.
I know.
Wait,
Details.
right.
Yeah, I mean it's like Yama.
Cool. And then we can have a Q&A, fireside chat, whatever anybody would like to ask more of. So, without further ado, let's get cracking. So, for me, this is the big kind of problem statement for me about why am I doing why are we doing this? Why are we building AI to help us do this? And it really comes down to so my company, we specialize in looking after Cassandra in deployments, across a broad variety of use cases, enormous clusters, small clusters, startups, banks, every kind of use case you can imagine. But this is a thing that we see all the time. It's usually that what happens at 3 in the morning when an alert gets triggered. Bunch of alerts fire out. You get a storm. Somebody's on call. They get paged. They've got a multitude of different dashboards for logs, for things coming at them, all the telemetry, all the observability. They still don't know what to do, and then they wake the senior guy at the end, and then it's taken sometimes up to 45 minutes, or it's an anecdote really, but it takes too long to figure out the cause before you even understand how to fix it. And with our clients, for us, what we found was approximately 30% of kind of your senior engineers, your senior Cassandra people, Kafka people's time is often spent dealing with reactive operations, just dealing with the problems. And that's what we've observed. So, and it often comes down to there's usually like maybe one or two people who might really have the depth of knowledge to look after things, but they can't be looking after something 24/7, 365, etc. So this is usually the problem where we look to kind of fix with the AI up stuff. So this is from I think from mine and from Patrick's feedback as well. This isn't new. This is just an evolution in how things have been going over the years. We started back in the 2000s with dashboards with things going red when they break and such, and then somebody picks that up, and then we've moved along further to observability, your Splunks, your Datadogs, New Relic, but still that kind of correlation between the logs, the metrics, what's happening on the cluster was very much required that human context to look at it. And now we've moved on to, I think, the next phase which is AI ops, which is AI is helping you understand, resolve the issues, and then act upon them. And that's where, for me, that's where an AI that's very much grounded in the actual cluster it's looking after, working over every single source of information, has every signal it has, and able to pull that information together quickly, give you an answer, as well as other things in there. And if you actually then, the usual people are worried about, am I going to lose my job with this? And I don't think so. I think none of these evolutions on tooling has really replaced engineering. It's made them more capable. And I think AI ops is really no different on this. I don't know, Patrick, is that something you agree with, or what do you think?
Well, that I kind of saw this coming beforehand, and this is actually when I wrote Jeff and I wrote our book about cloud native data. We were already seeing AI and machine learning. It was machine learning at the time having a outsized impact on how things are done. Look at like the Carpenter project with a K, how it uses machine learning to scale clusters. But I think at this point, all the bets are off. I mean, it's just, it's just really amazing how much, and I'll show you how I use it, but it's amazing how much you can just shortcut now.
Yeah, it's the
Um,
pace of change is it's impressive.
Yeah, the thing that I think about all the time is I can use Git like everyone else, but I just don't anymore. I just tell Claude, hey, can you rebase against this thing? And it does all the work for me.
I'm like that as well. I can never remember all the commands anymore. It's way too complex. And who
I
cares?
just don't want to do it. It's too
Yeah.
much toil. I don't want to do
It is.
it.
I mean, look, this is opinionated. I'm sure there's different views out there on what this means, but for Axonops and what we do, there's a very difference between what I'd call a dog versus AI ops. So these are not the same thing. Your DocBot is these are generic models that are really just quoting back the documentation. The problem with them, they're often wrong. They're often out of date. They don't really have the knowledge of the topology of your cluster, the configuration, the workload, or critically the history of that cluster as well. And they typically just have this tendency to apply principles from other tech because it's convenient, because it's desperate to give you an answer onto Cassandra and Kafka, which is dangerous. For me, AI ops is very much grounded AI. It's where you're deep in the tech. Yeah, it's not a generic thing. Yeah, and you're connected to that cluster when you're actually asking the questions. It's something that's been trained on Cassandra and Kafka specifically, or knowledge has been curated into that. So it really does know what it's looking for, and it sees that topology, the schemas, the configuration, the workload, the alert history, and a lot more. And then when it gives you answers to your questions, it's all contextualized to that cluster that you're looking at. And really, for me, that's the test question with these type of tools is, can it answer a question specifically about my cluster? And if it can't do that, it's a risky piece to do that, because always remember, this is data, this is a database. It's not some stateless application. And if you screw up, the blast radius is big. Yeah. So, and you have to take a very cautious approach here and really trust what you're using in there. And this is why we spent a lot of time working on this, curating on this. We haven't been throwing this over the fence as quickly as possible. It's something we've been quite careful on around that, and we've still got a lot further to go on it as well. So. And this is the thing we found with a lot of our that slide title could have gone wrong. Is depth beats breadth, yeah. And I've played with other observability AI pieces, and what I found was they're often quite generic. They have hundreds of integrations, and Cassandra or Kafka is just another one in the list of integrations they've hit. Often they don't have a core understanding of the actual things like repairs, compaction, the actual core aspects of Cassandra, or the same for Kafka. The other problem we find is they often have very short retention on the data. Also, they're typically downsampling the granularity of the metrics, so you lose a lot of the detail that you typically, well, no human's going to really worry about that. But that's the great thing about an AI, is an AI can actually look at very, very fine-grained data points and come back with good insights. So for me, they're good for watching things. They're good for stuff, but they're quite risky when it starts advising you what to do on your cluster or acting on them. So with Axonops, we took the view of we go deep. We always have. We build our tooling especially for Cassandra, especially for Kafka, and we've always gone very, very deep. And we took the same approach with what we did with our AI stuff. So it had all of the Cassandra, Kafka. These are first order concepts that the AI understands. And we also have the benefit because we're an observability and management tool. We have the full history of everything, all the metrics, all the events, all the alerts, all the incidents that have happened, and it gives us that safe amount of data that allows us to make informed recommendations about the cluster. So, and again, it falls back to my previous side that this is the stuff that's holding your data. Yeah, it's not a stateless app. You really want to be careful and make sure it understands it completely and it remembers what has happened before. And that's that's the view we take on that. So there's two foundations that we say you need before you start looking at AI ops. Is before any AI can help. Yeah, and this excuse me. It's any model you're using is only good as the context you're giving it. Yeah. So it's critical that when you're using AI to look at this stuff, that it has all of this information to hand to understand all of the metrics as fine grained and over time, all the different events that have happened on the cluster, the configuration. I mean, we have the configuration of Cassandra, the configuration of the JVM, the kernel configuration, absolutely everything about what's running and what it's running on. The schema, the key spaces, the tables, understanding, what is compaction, what is GC Grace, understanding all these attributes of the thing. The logs, Cassandra has an enormous amount of information that you do need from the logs, and it's a mistake to assume you don't. There's a ton of stuff in the logs that comes out from there. You fundamentally really need to see the alert history because it's not just the alert history on I've got a sudden swarm of alerts coming in, what's happening, but have I seen this before? Is this happened again? And if that extra information will not just help the AI, but it'll also help you kind of when it tells you this, actually, hold on, this happened last week, et cetera, et cetera. So that history is really important. And again, the topology of your cluster, the nodes, the racks, the DCs, the token arrangements, or the brokers, the partitions, et cetera, and your history as well. So it's really important to be able to look back on the history. Foundation two for us is if I'm going to do all this and I'm going to act on this data, I need a control plane that allows me to act on this data. So this is where giving you the recommendations, the insights that the AI gives you, and then acting on those recommendations. For us, it's the same thing. If you break it up, it makes it a challenge. I'm not saying it's not possible, but it's definitely a lot easier if the same tool is not just your logs, your metrics, etc., and your alerts, but also the control plane for doing your repairs, your back, looking at the history of your repairs, the backups, absolutely everything else. And importantly, the security, the role-based access control. So you have to be able to have that audit trail, that approval flow, those guardrails around it. So again, it falls back to the kind of classification of technology that we're looking after, where blast radius here is your data, and you've got to be very careful on what you're doing. So enough about slides. Let me just dive into the demo. What I'm going to do is, first of all, give you just a quick run through for the foundational stuff that sits in ActionOps, and then I'll go through the AI features we've got as well. So give me 1 second, and let me just share my browser. Hold on, there's a couple of questions there that popped up. No? Okay, no, it's not. All right.
No, it was me telling Rahul to turn off the notifications. Yeah.
All right. Where's my browser?
And then whenever you guys are mentioning links, I try to find it and drop it in because it gets stored in the chat stuff in the transcript. So
let me just, sorry, I closed everything to stop it popping up and annoying me, which included my browser. So, okay. So let me just share my cluster. So I don't know how, hold on. Where are we going? And
well, that was pretty too. Bring it back.
Yeah, there you go. Okay. So I if you've not seen Axonops before, this is it. And this is our tool to look after your Cassandra clusters or your Kafka clusters as well. So that as we're on Cassandra, let's pop into the webinar cluster as well. So when you connect up, what we have here is, as you can see by the rainbow of colors, this is not a happy cluster. And we will dig
Hold on. I see your first problem, Johnny. What is wrong with your topology here?
Well,
I mean,
well,
this is not a Cassandra topology.
this is your cluster. This is each DC, and this is each rack, and then this is each node in each rack. But I have to say, I'm not a GUI guy. I'm a list guy. So you can go in there and see all the
Yeah, I'll give you some
information.
real-time feedback. Fix that UX because I did not see that. It looked like, what is this kind of? It's
Yeah,
like a star tree type thing.
it's
Yeah,
like the
star
synapses.
topology.
Yeah, it's I think axons something to do with the brain and its synapses and things like that. But yeah,
Some brain stuff. Yeah.
but anyway, so in this tool, you get all of the observability you want. So all of the metrics, the law, everything about that's happening on your cluster. And this is where we found a big difference in the granularity of the metrics that really helps. So we have a 5 second granularity on all of the metrics that get pushed in. Plus, we have the benefit of being able to capture tens of thousands of metrics a second. So we're not white blacklisting metrics. We're not bucketing things up every minute. We have a very, very fine grained view of everything, which means you can zoom in to like spikes quite quickly in there. And then at the same time, we're also capturing all the logs about things. So when you're doing that kind of, and so imagine an AI, yeah. So this is where AI is zooming in onto a spike. It also has the context for the logs, same logs coming in for that window. Let me come back out, and then alerts. Yeah, so having all all your alerts set up there, whether it's metrics or logs, and also the history of those alerts as well is what's important too. So the AI is able to see all the metrics, see all the logs, see the alert history from the cluster, and then it gives it just improves and improves. Not that you want to have a lot of alerts going on in your cluster, but it does help for the AI to understand what's going on. And as I said before, let me go back into that as well. So when you look at each node that we're connected to, we're able to see absolutely everything about that node, both the kernel settings, the Cassandra settings, the JVM settings, the heap settings, the GC settings, etc. So we don't miss out on any of the necessary data points that we need to understand what's going on in there. So that's helps us a lot as well. And then it's also understanding what's been happening on the cluster with regards to say repairs. This is our adaptive repair tool, which looks after repairs for you. Yeah, we also have a node tool, scheduler tool to allow you to run node tool commands as well. So if those have been run before, we see this node tool command was being run, or maybe somebody has scheduled a bunch of node tool rebuilds and that's running. It's able to see, well, this alert's being triggered, but at the same time, oh, I can see you're running a load of node tool rebuilds. Maybe these correlate between what's happening on your cluster at that time. Similarly, rolling restarts, and then often we've had a few things triggered by backups, i.e., maybe they're saturating something or something weird going on. Having it be able to see the health and the history of all the backups happening on your cluster as well. So that's the kind of foundation one that I think you need to have at hand to allow the AI to kind of really understand what's going on. Any questions on any of that stuff before I start showing the AI, or Patrick? Any comments?
Well, you got the observability. So what do you do with it? I think that's I see what you're doing here. But this has always been the thing about observability is at this point is it's feeding the AIs.
Yeah. And
Yeah.
that's the gist of it. So what have we built? So let me come back to the cluster overview. So there's really three things right now that and this is live, this is being used by our customers right now, is we have a kind of an AI chat that it's allowing you to ask natural language questions of pretty much anything about your cluster that's going on in any topic that you get. And this is very useful for those kind of, questions like, you know, how's my cluster looking? Yeah, it will go off.
It looks funky.
Yeah, so it goes off. It looks at the current state of your cluster, all of your nodes, and it goes, hold on, yeah, I can see you've got 12 nodes. You've got a lot of alerts. Some of these are critical. We're seeing drop mutation, dropped hints, NTP offset issues. This is a really unhealthy cluster. We got nodes down. We got backups failing. We got things like that. We got some immediate actions. You got your drop mutation hints on this guy here are the most urgent. You got to figure out what's going on here. We got NTP skew, et cetera, et cetera. And so, but it's one of the things I actually was the other day I was working with demonstrating this to a security guy that I found quite really useful was this was a quite a cool question to ask. So I am being audited for ISO 27001. I am worried
Help me, please.
that
Yeah.
the cluster, that's a bit quite specific here, the Cassandra cluster is going to fail. Can you have a look and tell me if there's anything I should fix or look at before the auditors come in? And then it's going off again because it's able to look at all the settings, and it gives you a nice warning saying, "Hey, I'm not a compliance officer, but I can give you a good rundown on it." And this is where, so ISO 27000 is actually not to be boring. It's a good thing because it isn't just about am I encrypting this, am I doing that? It's also about resiliency as well and business continuity. So here it's going, okay, the security's looking all right, but I have some critical issues here that you need to address, and for your compliance team, blah, blah. And I'll tell you, actually, I'll show you this. This is even, Cassandra, to be honest, it's not that bad, but if I show it to you on a Kafka cluster, these are the ones that are usually got lots of problems. So I am being audited for ISO 27001. I'm worried. My Kafka cluster is going to fail. Sorry, my typing to fail. Can you have a look? Geez, my typing. Hey, look and tell me if I need to fix things for the auditors. Come in.
Come in and lock me up for being out of spec.
You'll find a lot more problems on Kafka clusters for this than Cassandra clusters. I can tell you that. But yeah, similar type of thing, and it really does come back with a bunch of quite detailed recommendations on critical data loss. You got topics with RF1, you got unencrypted traffic, you got node failures, you got connection failures. There's some high severity ones. You got things like auto create topics enabled. You got a low replication factor, single rack deployments, consumer lags, medium ones. You haven't got a min in sig replica, et cetera, et cetera, et cetera. So it really does allow, it's not just, is my cluster on fire? Am I getting these alerts? Why am I getting these alerts? It's also general kind of questions that you can ask of the cluster. So, and it's also quite educational. So I don't understand compaction that well. Can you have a look at my schema and tell me?
It's going to think you're an AI if you use M dashes. I'm just telling you right now.
I love M dashes. I don't know what you're talking about, man.
It's the little M dash that's human. It's the big M dash that's AI.
Right. Oh, yeah. All right.
Yeah.
Is it a hyphen or an M dash?
It's a hyphen. Tell me what compaction settings I am using. So,
but will it make the changes for you, Johnny?
We will get to that. We will get to that.
Yeah.
Yeah.
Because I'm super lazy. Super lazy.
Yeah, so here you go. Because we're able to see the schema, everything like that, it's pull out the compaction settings, it's telling you what it's using, it's giving you an explanation of it. And you can even dig in more detailed into the schema as well. So how is my schema model looking? Uh, looking. Are there any bad things in there I should look to address? Again, you can go in the schema. It's got all the stuff we've curated around that. It will come back and pulls it all out, processes the results, and then, okay, here you go. You've got some critical issues. You got a replication factor of 1. That's not a good idea. Yeah. It gives you the fix. Speculative retry on all your tables, very bad. I hate speculative retries. And so on. And no seed nodes configured, unused tables. We got 3 tables that we're not seeing any activity in there. But then you can also dig into things like capacity planning. How is my capacity looking? Again, do I need to add any more nodes? Nodes. I am looking at a 200% increase in data and traffic in the next month. Yeah. Again, it's able to go into the historic metrics, the rate of growth over time, how things have been performing, and it's able to give you a very good indication of what's happening on this cluster. So actually, here's my, I said, because I haven't got any load running in this, it says I haven't seen any traffic here. Let's pull back a little bit further, check the cluster data volume, no capacity directly, current state, etc. Capacity planning, okay, 10% increase. Okay, obviously this is a demo cluster, it hasn't got that much in there, but for now you're okay based on DIX, on disk. However, before adding those nodes, you should fix your RF anyway, because the RF is wrong, which has an impact on the capacity planning as well. So as you can see, you can be asking very, very specific questions on operational stuff, on modeling stuff, on general knowledge stuff around that. So that's the chat piece. For me, as I keep going on about, my favorite feature here is really the kind of root cause analysis on things. So if I go in and say, look at, so these are, let's just make this a little less busy. So you can see all the different things that have alerts on here. So I've got one alert being triggered here on the CPU usage on this node is pretty high. Okay, let's run a root cause analysis. So you click that off. The AI is going to look at everything that's happening on that node, the history of things that are happening on nodes, and in true demo effect, it will probably take too long to come back with the report. But there you go. It's analyzing, comes back, and hold your breath. Drum roll. Come on. Uh, what do you think, Patrick?
I think that you're relying on your live demo too much.
It's
Yeah,
live
I mean the
demo.
thing about live demos is they're always fraught with danger. Also, it's like we used to say I wouldn't work with children or or animals. Now I don't work with LLMs.
Let's run another one on some dropped mutations while that guy's running it. He's probably come back by now anyway.
You know
Oh,
what's funny though, Johnny? Because all the years of Cassandra consulting I've done, I used to really piss people off because I'd walk in and look at their logs in 5 seconds. I'd be like, "Oh, I know what your problem is," and then they'll be like, "No, it's not that easy." And it was always that problem because it's always the same problems and it's pattern matching. So my little, like
yeah.
my chip powered brain, my coffee powered 10-watt brain was able to do pattern matching because after a while my training algorithm was so good. Like every time you have this problem, you're probably using a SAN. What?
Yeah, exactly.
Yeah.
But anyway, so when the RCA comes back, you can see the report. It gives you a summary, the timeline, what the root cause is. It's not as experienced a partial network problem. It's been this server's dying, provides you all the evidence, gives you some remediation to kind of verify things, check firewall. This is more of a general thing, but if we look at, say, something specific to Cassandra, so say the dropped messages one, did that come back? Are you still analyzing it? But there you go. And then here it's saying, okay, you're getting drop messages, drop mutations, pretty sustained rate there. There's severe clock skew. We've got NTP offset issues, sustained CPU saturation, et cetera, et cetera. It's providing you with the complete timeline of everything that's relating to that. Gives you that understanding of the root cause. So we're getting drop message. We've got a lot of NTP skew, CPUs being hammered. The sequence is the clock skew causes the write coordination failures, increase the CPU load, blah, blah, blah. CPU saturation blocks the mutation stage from draining, blah, etc., and so on and so on. And then it provides you with the actual evidence on this. There's where we're seeing the drop mutation shows it consistent. We're seeing NTP alert firing, again, correlating this alert to another alert in the system. CPU one dropped hints. We're also seeing dropped hints, etc. And then we provide the remediation. You need to sort out your clock skew, the CPU saturation, and here's the kind of prevention steps in there. So like that, and that's a complicated one. Yeah, that's one of those kind of alerts where it isn't just I can look at HTOP or DStat and figure out what's happening. This is something that's like a chain of things going wrong that it's able to give you a good root cause for what's caused these drop mutations. And that's when this would take you a long time to pull together, or you'd need to be Patrick or I dare I say Johnny to figure this out. Here, this is someone who doesn't need to call me at 3 a.m. It can be someone who's limited experience, and they're also being educated about Cassandra at the same time as well. So it reduces the noise, reduces the burnout, gets your root cause, your time to resolution much quicker in there. And I think this is a kind of a killer feature for me, because not that I have clusters with lots of alerts, but when they do happen, everyone panics, calls you up, et cetera, et cetera. And then the final thing we've built is this recommendations engine. And again, it's like having an architectural review on demand. This is one where maybe I'm doing myself out of a job, because this is where I'd come in, do those architectural reviews for people. But now you just go in, click a button. You can focus in on certain domains as well if you like. You can focus on security, configuration, absolutely everything you'd want to know. And then while that's running, I'll show you the one from before. And then here it comes in and gives a whole bunch of recommendations with the details. Yeah, it's not just do this. We provide the rationale, the suggested action, everything down from you might want to use Shenandoah instead of G1 on this cluster, or we're seeing excessive heap allocation, inconsistent heap sizes, insufficient seeds, then into like reliability. We're seeing dropped hints everywhere, down to the kernel level. Yeah, we're seeing the network kernel setting dropping packets. This is set too low. Your compaction throughput, it's quite conservative. You've got the headroom to beef this up. It's and so on and so on. And yeah, there you go. So that's where those are the three kind of read-only features that we've built. What's coming next, or when we get it built, let me come back to PowerPoint. So before I move on for the demo, any questions?
Yeah, I had one. It looks really great. How much of this functionality that you have on your platform do you expose with kind of the protocols like MCP or ACP?
Yep. So we have an MCP server exposed. You can use MCP to connect up to it. It's obviously you got to be careful. It's it's people's production clusters and such. But yeah, we've basically got a whole very rich set of tools that we've used. We've created MCP tools. So all of those things you're seeing there are interacting with a bunch of MCP tools that them themselves are actually using AIs often behind that tool.
Yeah.
Well, broadly contextualizing it. We have a whole bunch of knowledge that we've created in a kind of a RAG type of thing behind those as well. We've got some of the tools are, you don't want to go crazy, as in like, this does not need to be done by an AI. This is an if-else kind of question type of stuff. So it's finding that good balance between something where, this can be done with just a bunch of switch statements, as opposed to this is something to that. But yeah, there's a whole bunch of MCP tools. Right now, they're really more geared for what we're exposing through our platform. AxonOps itself is API first for everything. So absolutely everything I showed you in the GUI in terms of setting up and configuring, it's API first across the board. And the MC piece is just a natural kind of extension of that. So yeah.
Yeah. And the follow-up is, do you have on your roadmap ACP or A2A? Because they're not the same. Yeah.
Yeah,
But,
yeah. I'm looking at it. It's I'm not going to lie, I haven't dug into it in a massive amount of detail. But I am interested in the agent to agent stuff. Yeah.
yeah.
I think that's how this is going.
Yeah, because the way that you're showing your product, right, there's a lot of intelligence built into it. What the A2A and ACP do is they go beyond the tool, meaning resource, I need this, I need that, to I'm going to give you a task. And then the ACP kind of manages work sessions and it reports back. And I think I see that already in your product. That's why I was asking. Yeah.
Well, that's kind of what leads me into what's next, because that's where the next phase of this is. It's going from something that's giving you advice to actually enacting upon that advice, and that's very much where I think where the A to A stuff, the agent to agent piece, needs to come into play. Because with the whole different, I mean, if you have a flow where the AI says, "Would you like me to do that for you?" and someone says yes, well, okay, fair enough. That's someone where there's a human still in the mix, and that is what we're going to do first. There'll always be that, yes, I want to do this, and as this grows in, I think, maturity and safety, I'm absolutely paranoid about this messing up. We've all heard I mean, I've actually had Claude do an RM minus RF slash on my thing. It did happen. Yeah. So this does happen. So having the necessary guardrails where it's not just that I don't want it to do this because it's stupid. I don't want it to do this because that's how I want my cluster to be. Yeah. And this is the thing about Cassandra. It's a very forgiving database. Yeah. It's for me, it's a database full of compromises. Yeah. People use it in the purest sense, but there's always situations where, look, I have no choice. I have to just do this. This is just how my life is. This is going to do this. I can't change this configuration. I cannot get off a SAN. I have to be running on VMs. These are the things that are out of my control. So what I'm interested in that side is not just this straight up, can you obviously create that alert for me, change that piece of configuration for me, but also the understanding of the history of why I've done this as well. And that's where the agent to agent piece, because there's also a question of separation of concerns here. Yeah. And just like you would have with a human team. Yeah. Is it the same person doing this, that the same person is doing this? So that's where I think the agent to agent stuff really comes into play, is whether somebody has their own agents that they want to use to perform these actions, but they want us to inform them that this is the action to perform, or it's our agent sitting next to their deployment performing the action for them. And it's an interesting ecosystem. I'm not seeing a lot that's kind of plug and play, if you know what I mean. But the A2A protocol stuff, I think, is what's going to give you that. This is my agent, how I want to be running AI ops on my tin, but I'll use your agent to help me make the decisions, but I'll enact them. Yeah. And
yeah.
But this is the next phase of it. It's going from this advice to action. Will I set up that backup? Will I run that rolling restart for you? Will I set up an alert for this for you? Will I change that piece of configuration for you? And then next phase is let it at it, and with a lot of guardrails, a lot of guardrails to do this. So, but yeah, it's production, it's data. You really don't want to mess around with this stuff. So
we should get moving here, Johnny. We have stuff to do.
You're going. Sorry, mate. I waffled on. Over to you, Patrick.
That was a lot of don't let AI just do whatever. Yeah. I agree. Yeah. Well, I mean, we've always done this, and I'm going to talk about this a bit right now. Is even with humans only doing the work, you still have change sets. If you're in a highly regulated environment, you're in a controlled environment, you are not going to just SSH into a machine and make a change. If you are, you're probably working at a startup and you don't care. But if you're working in any size environment, you're going to make changes on a schedule. Next slide. There we go. So here's I'm going to talk a little now for something completely different, but the same. This is one of my current projects. It's actually something I'm spending a ton of time on. And Rahul, yes, I'm going to do a Planet Cassandra meetup on this. SQLite, if you've been following me on LinkedIn on some of the stuff that I'm doing. It's what I built was it's a Rust library that reads and writes SS tables out of band from a Cassandra cluster. But what I'm using it for right now is really, really fast analytics on Cassandra clusters without having to change anything. Thank you, Rahul. Without having to make any changes to your Cassandra cluster directly. It'll just use the data that's in there. And so, your Cassandra cluster is Cassandra 5 only right now, because that's what you should be running. But it uses the Cassandra Sidecar project which already has all this information about the cluster. It looks at snapshots. SQLite reads the SS tables, but part of what I built is it also puts everything into an arrow format so that I use the arrow flight project, and it makes it really easy to drop into like something like Trino or Presto, things that can read data fusion, things that can read arrow directly, and it makes analytics really fast. One of my goals for this is to make it as close to Parquet speed as possible and stable. Next slide. So here's the tool I'm using, EasyDB Lab. Now, is this an AI tool? It didn't start out that way. It started out as just a way to bring up a cluster and test some stuff out really easy, hence the name. This is John Haddad. I think he's done a meetup on this particular one. And if you look through the archives, you'll see it. And he's very proud of this. If you wanna hear John talk about it, just ask him. He'll tell you all about it. I've started being a contributor on this as well because I love it too. So it automates. This is just runs on Amazon. If I had my way, we're going to get it on Google too. But it sets up a real cluster on real hardware, real machine. So it's not like a little Docker container on your machine. It's a real cluster, so you can test it as hard as you want. And it brings up any version of Cassandra you need, and all the configuration is code. So I'm setting you up here. It's like all the configuration is versioned, and then you try different things, and you could try, an idea, and then if you can watch it fail. But it also has tons and tons of observability with Prometheus and Grafana. Does flame graphs, use OTel for all sorts of stuff, which is critical whenever you're testing something and trying things out. So, in caveman days, back when we lived in caves and set up clusters, we would have to do this manually like savages. We would actually have to type on the keyboard to change configuration. Not anymore. Next, please. So what I'm doing now is I'm testing configurations with the AI. There's a skill that's built into EasyDB Lab that lets me fire up Claude Code and say, I want to test some things. And so now I just say it. I'm like, and this is the thing. I'm going to say, does this actually work? And so I've been using it on SQLite on running Cassandra clusters to try out different things. And a lot of debugging, really, like, hey, does this work on frozen UDTs? I don't know. Let's go find out.
Yeah.
And, I say that because that's exactly what I'm fixing right now. Frozen UDTs. But one of the things that I did is I said, build me a test plan that covers all the different syntax in SQL and all the different syntax in CQL. And it built out a really comprehensive plan. Nice. And I was like, perfect, go destroy this thing. And it is. And so I just say, does SQLite read every field correctly from Cassandra 5? And so what it does, it says, okay, I'm going to make the plan. I don't have to hand edit it. It does the provisioning for me, and it just tells me what it's doing. It asks me questions along the way. It says, yeah, I'm going to use a 3-node cluster using, 4i4. Does that work? Yeah, that works great. And then it starts doing the test, but then it automates all the reading and pulls all that information, all the log files. And a couple of situations where it actually has had a problem. It's like, something bad happened. I can't read this. I'm like, go get the log files and attach it to the issue. Okay, got it. And then I use that issue later with the log files. It'll even take snapshots of graphonographs. So like it's really spiky or something. Like it'll take that, attach it to the issue. This is like all stuff that I'd probably do anyway, but now it's all automated and I could just iterate so fast. So it'll run the loop. And a few times I've even had it like try a couple of different things just to try to like play around with the outside of it. But it's all narrative. I'm like, does it do this? Oh, try this, try that. Okay, tear down the cluster. We're gonna go fix this. But this is almost like having it is. It's like having a human assistant. Um, Back in the day when I first started with Cassandra, the company I was working at, I was running engineering, and I had a few interns doing some testing for me. And it was pretty much the same conversation. I'd walk into the room where they were working. I'm like, okay, guys, today we're going to destroy something. Here, do this, do that, do that, and let me know what happens. And when it broke, they come in and tell me, and I'd say, oh, we'll try this. Okay. And then they come back with logs and things. Same thing, except now I have this thing doing it all the time. So it's just, it's not that this is smarter, it's just compressing the iteration times, which is really killer. And what you're going to get out of this is two things. I'm doing this right now on Cassandra 6, and I'm building tests on some of the things that I have failing. I'm doing this right now with SQLite. It's compressing things. Like every time I find a problem, I have it create the tests, I have it create the validations, and then I figure out how to fix it. Okay, next one. So here's an example. I did 4 fixes really fast. And here was the parameters that I gave it. I said, I want a really strong soak test. I did it for 90 minutes and it ran. It did tons of partitions, like a real number of partitions, not like, oh, here's 10 records on my laptop. No, 1.7 million partitions. That's a ton of rows. And, I did get an error rate. Oh, okay. So I pulled that out. I got this do get error of 0.026, which doesn't sound that much, but I dug into it and I found out why. And it was because there was some weird problem with like it would just like when it was under saturation, it would start splitting. And the memory was inside it's all written in Rust. And so it was doing splitting. And so it wouldn't see each other like details. But anyway, tiny little problem, but it only showed up under soak and it was easy to diagnose because I'm just like, go find it. It's like, found it. It's over here. Awesome. So actually, this is really new information. I put this up last night. I'm running the test now on this fix. And, I have a cluster running right now with this fix. And I'm trying to get close to 100,000 QPS per node. And this is the way I'm trying to get there. And, fixing these little problems. And it's iteration after iteration. I noticed that my BTI stuff I didn't have enough test data for BTI. All right, I need to go create that. So that, just little things. And I'm orchestrating it using, language instead of code at this point. Next, please. So this is just kind of my generalization, and using AI, not just for fixing your production clusters, but also iterating on things to think about. Like, this is where we are. If you're thinking about upgrading to Cassandra 6, for instance, or even you're on Cassandra 4 and you want to go to Cassandra 5, setting up a test lab, trying some things out, and even optimizing is the best thing you can do, right? And where it used to be, it would be like months of your work or lots of instance time on EC2, because it takes a while for a human to do the work. What could you do if you could do it faster? But the important thing is not using AI as smarts. You're using it as the automation. This is like advanced scripting, because that's how I treat it. I don't treat it as a smart thing. I treat it as a scripting tool. It's like if Bash had a little bit of a brain. And I'm a big scripter. I've DevOps my way through life. And so this is what makes it good for me. So this thing here is like, so it's all about grounding. I actually do real things on real clusters, and I test. I do like Oracle testing on SS table dump. I can throw a lot of complexity at the different test scenarios instead of just eyeballing it and saying, yeah, that looks right. I can say, all right, do an SS table dump. Okay, do a destruction test. Okay, do a survivor test. Like all these different things, the cost is low. Grounding, it makes you do better grounding, which is always the key. Um, and then the life cycle, that loop, go fast, go fast, go fast, iterate quickly. And then to Johnny's point earlier, it, the humans, I'm still the person saying what's up. I'm the human. I have judgment. The AI could say, looks good for my house. Sure. It may, because it's under some threshold, like 0.026% error. It might just say, yeah, that's good enough because it's less
Yeah.
than 1% or less than 0.5% or whatever the accepted norm is.
Yeah. They're
But
very
I'm
good
like,
at telling you there's no problems.
exactly. It's like, yeah, it looks good. Sure. Yeah, ship it. No, I got to make that call. But also, I got to make the call on the type of test because I know it can say, oh, you know what I'm going to do is send it a cluster and hammer it with a particular workload. And I'm like, you know what I'd rather do is a ledger style time series model that uses tiny UID because that's what I think is more important for this type of workload. And I'm making that call. And then it can go do that and then do range queries and aggregations and Trino on top of that. Ooh, that sounds interesting because I can see that. That's a human. I'm making a judgment call. It doesn't ever come up with that, ever. But then if it makes changes too, it's like, all right, I say I want to try something new. It'll say, okay, I'm going to make these changes. Cool, do it. Go burn it. Or hold up, yeah, we're not going to do that. We're not. No, we're not going to change GC Grace to 0. Um, not going to do that today. um, so it stopped me from shipping something that was a little bit broken. Like 0.026 is piss you off broken. It's not like epically broken. It's the one time in a million or one time in 10,000 that you'll be like, oh, or it's actually be two times in 10,000, one in 5,000, that it would make you angry. And on a large scale system like Cassandra, you know that that's a bad idea. Like I remember one talk from Apple. They said, if there's a problem that will happen once every 100 years, statistically, we'll see it like every day.
Yeah, I know yeah, but it's fantastic with its ability to kind of brute force those problems with with everything that you would spend so much time yourself figuring out every single thing to test, to validate, to run. I find
Yeah,
it unbelievably useful.
yeah. And EasyDB Lab was great, but now it's amazing with the skill.
Yeah.
And it is so fun to watch it work. Like, especially if you give it like an environment to work from and you just say, you give it a test plan and say what you want it to do and just sit back and watch the thing work. It's really good at it. Like
Cool.
Claude is amazingly good.
Yeah.
I think that's all I had, Johnny.
Okay. Well, I mean, it's perfect timing, mate. That's so yeah.
Yeah.
So in summary, we've covered a lot. We've gone through the AI ops stuff, what for me it means, what it means for our tooling. Things are changing. I mean, that resolution in seconds is going to become the norm. The expertise being the knowledge being spread broader. You do not have to be a Cassandra super duper subject matter expert. You can be a fairly capable person joining a team, immediately bringing value in. And the tools like with what Patrick's discussing shows you how you can really kind of just innovate at a pace that would be unbelievably expensive and slow prior to all this stuff. So yeah, so things are moving fast. Um, so yeah, thanks very much, everyone. We're open to hanging around for longer discussions, questions. If anybody has anything they'd like to ask, I live in Luxembourg. It's 8 o'clock in the evening. It's eating into beer o'clock, but I'll happily hang around.
Well,
So
let's if you could take down the screen share that we can see everybody's faces. Thank you so much, both Johnny and Patrick. Appreciate you walking through your work and how AI is helping do great things without great strife. I think that's really what the cool thing about AI is. you can do so many things that you would have been like, oh, I don't know if I want to do that. That's going to go in the backlog. And now you can just be like, let's try this out. So it's really cool to see both you, Johnny, and your product mindset of making something that serves many, many customers, and then on a different type of product, Patrick, where it's kind of like a utility, but it's a very powerful utility that can go into somebody else's workflow potentially. I'm really keen on seeing how you've bought into the loop, which is like the joke. It's like loops are dead, loops are everything, loops are dead. But it is about this kind of like overall process. The cycle is the product. Eventually, like you want the harness to just control different parts of it. So maybe in a few months we can see any updates from you. I know I got Patrick coming and talking about SQLite soon. But hopefully in a couple of months, Johnny, when you get A2A and ACP connected, it'll be cool to see that happen.
Yeah, yeah. No, as I said, I'm very cautious with this stuff because it's data. Yeah, you don't mess around with your production database. So yeah,
That's what no, that's why SQL using EasyDB Lab is great. You can
yeah.
just have fun on a database you don't care about, but that's actually the point is, do the wild stuff in the corner in a firewalled area that just doesn't have any production. But then it does really give you peace of mind when you do something, especially if you're trying out new things. You could, I think that that's one of the things that we've done for a while is, copy off your production data into a test environment and then go try stuff. That's probably where we are now with most of the AI stuff is you can do things, but do it cautiously, but you will get good results. There may be shenanigans at some point, but you will get good results because, there's just the models are really advanced and we're learning how to express our harnesses. And EasyDB
Well,
Lab is like a harness.
on the models piece, that's one of the. There's only a certain amount I can share, but one of the things actually we found was you do not need Fable, Opus, GPT 5.6 to do this stuff. So we're able to run with fairly small, cheap models for a lot of our all the AI stuff in Axonops because, and it's we were actually genuinely surprised how once you stop relying on the trained Cassandra knowledge in those general purpose models and you're prioritizing your own knowledge, all you're really looking for is that, how do you say, reasoning of it, and really can it take the context that I'm giving it, and has it got good maths? These are the things. So yeah, you don't need to be using heavyweight models for a lot of this stuff as well. We're finding they're just getting better and better and better and better. Hence my earlier question would have fit on my 4090.
Awesome. Yeah, I think the open models are going to give a lot of promise to all users, especially stuff like Kimi K3 and GLM. I imagine can do everything that Opus and Sonnet can do at this point. Fable is like at the top, but I think the cost of doing this is going to go down, right? Like that's something that I'm looking forward to. What I'm also like looking forward to is that people embrace this harness loop idea and that they kind of like you're doing, you and John are doing, Patrick, you're putting it into the product that there's some sort of like component that it's doing a really good job of, but it also has a cycle, then your meta process can rely on that cycle, right? I just put some notes down that maybe we do a session in the near future about how to set up your harness for Cassandra development. I think that would be an interesting kind of hands-on type of thing to show people,
Yeah,
hey,
that,
Yeah,
let's set up a
I
harness
agree.
for how would you do compiles of Cassandra deployment. Because what you just showed, both of you guys, it's like, that's great. But then can you show me how to do it on my local computer to build my next application or my next Cassandra build?
yeah,
So thank you.
cool.
Well, John's Cassandra skills, as a plugin, that is the first place to start. I mean, that's an easy one right now because it has two things: it has operations and it has development. And there's been some great contributions in that. And it's useful whenever, especially to provide context in anything you're doing. So like for instance, if you're doing an app and you want it to data model correctly and not do something stupid, it just provides enough context. And I've used this myself because it just keeps the model focused. um, I don't have to tell it to, no, you can't do a join, or no, you can't do a group by aggregate. And but it also then it learns how to do things that are a little less clever, like how to use an SAI properly. And on the ops side, it's really good about making sure that you have a good configuration for like compaction, just basics.
Yeah. Yep. And actually, John's talk on his skills is on the Planet Cassandra YouTube. Feel free to check it out. I just dropped a link down there on our Zoom chat if you need it. Any questions from the crowd? You can drop them in the chat or you can raise your hand. Give people a few minutes.
Yeah, so while we're waiting, one of the problems we for us is we have quite a broad set of customers using Axonops. Not everyone's running on AWS. We have people running in air-gapped, bare metal environments, like payment uh, processing platforms, banks, things like that. And it's really interesting to see how you're able to get this type of technology into those restrictive environments. And this is where, like, for example, the just call out to Anthropic and you're all good. It's like, no, 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 no. This stuff is not going anywhere other than in my
Mhm.
environment. And it's actually been one of the it's a core principle for what we've built is because we have to be able to support not that we don't mind supporting, we want to support those customers. And it's what I'm looking forward to see is how are these type of highly restrictive environments where you just cannot do that. What are they going to do? How are they going to bring this AI model into those environments? And we're seeing a mix of literally people, hosting their own models on their own servers in these environments, and a lot of them don't trust the kind of enterprise. We won't look at your data guarantees, particularly in Europe, as you can imagine. It's
Oh,
an
that's a hot topic. Yeah,
very hot
yeah.
topic in Europe is this, you know,
It's a hot topic in the US. Alex Karp from Palantir made
yeah.
every CEO freak out. Like, wait a minute. You mean all our data is now getting exploited by OpenAI and Anthropic?
Absolutely.
Yeah.
How'd you like to be on that sales team right now? Every phone call they're in, they're like, no, we don't steal your data. No, we're not doing
Yeah.
that.
We promise we won't. That's my favorite.
Yeah. Did you read the terms of service?
Yeah. Yeah. Well, no one ever reads the T's and C's. What's that episode of South Park? No one on Apple iTunes T's and C's.
Yeah.
Yeah.
Just click through.
Yeah, that particular use case, it's funny, Johnny, that's exactly the challenge that
Yeah.
we're working on is we're deploying AI to be able to deploy to the edge and private data center, which is not the same, but it's similar in the sense that you may not need to call out to Anthropic, but it needs to work out on the edge without an internet connection.
Exactly.
And the innovation in the open world, it's all happening in China. All the open source models are in China, the best ones. And we get excited about it, and then it's like policy. Oh, well, we don't know if we're going to allow people to use Chinese models.
It's going to be I mean, certainly in Europe, Mistral's obviously pretty popular, but there's a much more appetite for, I think, these open source models that
Yeah.
you can essentially keep within the how do you say it, keep within your kind of boundaries on what's going out. And it really depends on a lot of people's sensitivity to that, I'm finding. And I'm brushing up against it a lot more. I was in India for a while ago for open source India conference, giving a talk and doing a kind of a quite interesting road trip around. And what was really surprising to me was their sensitivity to data sovereignty now is becoming. They're like, there's a lot of people saying we're pulling out from your AWS, we're pulling out from your SaaS servers for both the cost perspective and a privacy perspective. And the interesting one recently was the Airbus migration of AWS onto Scaleway for that exact reason. So it's a so the point is with our stuff, we're basically we'll point out whatever you give us, and that's why the being able to work with cheap models that you can self-host that do not need like a million context window or can run on a 4090 or heck, I've tested it running on a Mac Mini M5 and it was reasonably good, to be frank. So yeah, it's a rapidly changing pace, and it's interesting depending on where you are in the world how that perception's different.
Yeah. Yeah. What I've noticed in the skills world, and I think maybe, this is the part about when you're making an AI product, there's so many different ways to instill the knowledge, right? Apart from the model itself. There's skills, there's data, there may be knowledge bases that are not just skills, but more knowledge that are referred to by skills. I think testing it on different models is the hard part to get a generally good outcome repeatedly across two or three different models. Then you can be like, my skills are good for different models. Because if you're just in the Claude world and you're making skills and you're just using Fable,
yeah, everything's rosy.
everything's great. And then you drop it in, GLM and it works, but then it doesn't have as big of a context window or whatever. That's ultimately those are the type of things that we see. But yeah, go open source and go sovereignty, right? It's all about AI sovereignty.
Yeah, it's a rapidly hot topic. It's
Yeah.
yeah, it's going to be quite an interesting time over the coming years. There's certainly in Europe, there's a big concern now around this. So, but I mean, I love them. I'm a big fan of Cloud myself, so I'm not going. But it's fun.
Fable's legit. Fable's
Fable's
legit.
legit,
I
man.
mean,
I mean,
Fable is
you say that.
found so many things.
I mean, like I've been where I'm finding Fable very useful for is analytical type of problems where it's having to connect that graph, it's having to connect things like that. But I'm finding with the code stuff, not much
And
much.
here's well, here let me help you out here. So here's how I use Fable, and I found great success. First of all, it is an excellent orchestrator because it is very analytic. You're right.
Yeah.
And so what I do is I use Fable as like the boss, and I make sure I use workflows, and I have it use sub agents, so it can run. I just did. I was just looking at some TCM stuff on the Cassandra cluster, and I had Fable spin up several hundred haiku agents to go look at different things. It's really good at doing that. So that it spun up 400 haiku agents, sub agents, and was looking at things. And then it decomposed those using Sonnet. And then from there, it orchestrated some different fixes. I've had Fable running on diagnosis and fixes on certain things as like the master agent, like the thing that's doing the work, and it's run for 5 days. It just it is just relentless. That's the thing I love about Fable, but it's really good at dispatching work to a perfectly fine Opus, Sonnet, Haiku. They can do a lot of the work,
Yeah.
and I think that's the superpower. It's able to just do these long, drawn out, important things.
Yeah, I'd agree on that as well. It's yeah, but yeah, but yeah, I think I agree on that. I'd have to have a play,
Yeah.
not or you can have to show me how you're doing it. Be
Well,
interesting.
it's really simple. You just tell it you are the organizer of this event. Use a and I found the keyword is use a fleet of subagents, and that triggers the workflow activity. And
Okay.
just sit back and watch. Yeah, that's and don't have it do the work itself
Yeah.
because it's just a more capable model. It's not that's not the superpower.
Because
It's when it organizes.
I've done that with that kind of Opus hybrid thing where you can set Claude
Yeah.
use
Oh, the team leader.
yeah,
Yeah. Agent
Opus
teams.
in the cloud, but when you dispatch the agents, use Sonnet or whatever.
Soul does this too, by the way. OpenAI Soul,
okay.
Yeah.
the it will do is, but Soul is like the peak. In my opinion, is like the peak of the GPTs. It's like so tweaked out. It is like at the end of, where Fable is a different kind of model, where it's way more organizational, for lack of a better word. It thinks more like an organization and long tasks, where Soul is just like super analytical. It's like, I will find the bug. But it also has the ability to run multiple subagents.
I'll have to give that a go. Yeah.
Yeah, this is how I'm using it, and it seems to work pretty
We
well.
we should
Yeah.
just set up some kind of regular session on, you know,
We just did. Like,
yeah,
a lot of people are still on there listening to us yammer on about how we use
yeah,
AI agents. Oh, Gil showed up. Gil loves to hear me talk about how I use AI agents.
yeah.
Yeah, I think from a Planet Cassandra perspective, we are gonna start doing more frequent meetups. So right now we do like once a month. We're gonna start to do them every other week, um, with the intent that big part of it is related to AI enabled work, whatever that is, AI enabled engineering and AI enabled architecture. Because like you were saying, Johnny, like you use this, you hand this task off to the AI. We used to be that person, right? The work used to come to us, operators, engineers, architects, to do this work. Now the AI is doing it. So what is the actual user of Cassandra now? They're an orchestrator themselves, or a captain, if you will, of a fleet of agents, right? And so I think it's important to continue to teach people that this is the future.
Yeah.
This is the future.
Yeah.
So if we want to have another, I mean, we kind of had with John did one on skills maybe a month ago, or maybe it was a couple months ago. This is another AI enabled one. Maybe we'll do another one, in August. Um, it's important to kind of keep this front and center for folks. I mean, not everybody's doing what you guys are doing. I mean, you're at the bleeding edge, and I would say that in the Cassandra world, we can do a show of hands. Who here is using Claude or using AI-enabled workflows on their production at work? You guys can just either put it in chat or just raise your hand. I'm just kind of curious, because I think it's really restricted in a lot of places. I think that's what it is. Nobody wants to tell
All
us
right.
anything.
Nobody wants to say, yeah, no, it's shadow AI.
They are using it, but they don't want to tell
They
anybody.
don't. I'm not telling it if my boss knows.
Yeah, that's when you have your Claude subscription on your personal Gmail. Wow, you're so productive. We don't even provide AI. I know.
What's that? The Simpsons episode, the knocking, rolling thing, pressing the button. Yes. No, two.
I mean, there's a lot of benefit of, like, at least right now, right? If you pay for the Claude organization, you can share skills, and that is huge. Having a shared skill registry is very useful.
Yeah.
But for now, it's like three people using Gmail backed Anthropic accounts. The Git repo is just as good. So.
Yeah,
I mean,
I agree.
it's also it's cost prohibitive as well. I mean, if you're using the APIs, man, like obviously Max and Pro, you got pretty good utilization on the kind of consumer grade accounts, but the API level costs are.
The only people using APIs are people with an enterprise account, and they're getting the cut rate price anyway. Yeah, I don't know anyone that's using the API, and why would you?
Yeah,
You do.
yeah, I do. And a couple of I obviously can't say who, but a couple of banks, and I'm like, I am blown away.
Well, they use enterprise pricing now. They're getting enterprise pricing.
It's like,
yeah, no, that's common. That's really common. The enterprise pricing is pretty good.
But like 400 or 500 people given $1,000 a month in API usage, and I'm kind of going, what?
Yeah. But they're not paying list price. Like if you and I went on there and paid for API pricing, that's not what they're paying. They're not paying that. And I have a lot of customers
like
that do that.
Whatever is being spent, right? We're talking about human time and AI time. So even if they're spending, whatever, You said 500 people with $1,000 each. So that's $50,000 of tokens. $50,000 of tokens is like five, full-time people, $120,000 a year, right? Like $50,000 of tokens in human time versus AI time.
500 by 1,000 is
it's 500,000.
Right?
500,000.
Still,
Yeah.
$500,000, right? That was a bill
How many
that
R's are in
AWS had.
strawberry? Tell
By
me,
the way,
Rahul. I want to know
AWS
you're
has,
not an
has
AI.
even a bigger bill from Anthropic, right? They figured that out, right? So let's just say 500,000, right? $500,000 of human time, right? Versus $500,000 of AI time. AI time is like eons more than human time. So as long as they can get the value, who cares what the cost is? Because if you have to spend the same time,
it depends who's paying the bill, I think. At the end of the day, it's and like I mean, like $500,000 will get you a lot of very, very smart engineers as well. So
yes,
it's this cost benefit analysis you got to look at.
right.
I think there's a danger of it because I mean we're seeing everybody complaining about this now. Is that
Oh yeah,
if the bills are coming in and they're realizing holy hell, this is a lot of money I'm paying. So it'll be interesting to see how they somebody's it's just point return on investment,
yeah,
which is exactly the
yeah,
right thing to say. And yeah, but I mean but I think you put in crap to Claude, you give crap requirements to humans, crap comes out the end
yeah.
anyway. And what I'm seeing as well is people not they're wasting the tokens, they're wasting their
Oh
money
yeah,
because they
totally.
just go make me something that does this, and then it goes off and comes back
Oh
chunks
yeah,
of money. And
yeah,
I'm a big fan of BDD for all of specification based
yeah,
environment. When I'm building something now, it's BDD test the hell out of everything. And what I'm finding is Claude or whatever, when something breaks, it because the test is expressed in human language, it's actually much more quick at understanding, okay, I've broken that requirement. Now I understand what that requirement is. So taking a BDD or things like cucumber approach for how when you're building stuff is absolutely my top tip. You just
yeah,
it ain't if it doesn't have a BDD test, Claude, it ain't written.
yeah,
Yeah. And
yeah,
also BDD test black box as well. Don't be it is it's that's what I always try to do is I fire up whatever I'm building in a kind of a integrated fashion, and I have a massively comprehensive suite of BDD around it, and then I'm confident that I can go clickety click do that, and I haven't
yeah,
regressed, I haven't broken because what I find is Claude's quite good at going in and making unit tests pass, yeah, without actually understanding what the hell it was actually testing. I found a lot, but that BDD,
Just recently did a talk on O'Reilly about that. Like how to keep your
locking,
AI from lying to you. Yeah, it will. Well, unit tests are junk. I mean, they're great for some things, but it's you can go look at SQLite directory or all the project, and I have everything in there. I use OpenSpec. I
mhm,
use very strict gating on the CI,
mm,
and then the testing is all based on real end-to-end testing with Docker. So it's comprehensive, but it's also really brutal. I mean, it can take hours to run a full
yeah,
CI, but it's the only way that you're going to know. Uh, I have a ton of unit tests. I have a bunch of end-to-end tests that are super like they're focused, like really focused on one thing. But the real tests are always like the Docker tests. Like go spin up a Cassandra cluster, write an SS table, now read it. Okay.
yeah,
Did it work? No. And why? And yeah, so there's tons and tons of telemetry, tons of OTel. Just because we're at the point now where you can't just do a unit test and
yeah.
expect it to work.
it's sycophancy and hallucination.
Well,
Well,
the
it's
whole,
goal setting.
yeah,
It's
the whole,
goals.
yeah, the whole cycle.
Observability driven development.
Yeah, goal driven. No, no, but that's right though. It's like you you have to kind of know the big picture of what is it that the whole thing needs to do. And I think a lot of waste that we hear about, the tokens being spent on dumb things. is maybe 10 people in a team that don't share knowledge. It's the dumbest thing. They are all
Yeah.
reinventing the wheel, right? They're all doing the same thing, but they're doing it in different ways.
Absolutely.
And if one person made a skill that was efficient and everybody used it, then 10 times that savings comes back, right? And they don't do that. It's the same shit that happens everywhere. A lot of smart people, but they don't talk about like what we're talking about now. We're learning together. I think organizations that don't learn together, they end up making the same mistakes over and over again.
If you don't know your history, you're doomed to repeat it.
Exactly. Exactly. Exactly.
Yeah, it's
Um,
one of the things I've decided to do with my open source projects. Like SQLite, there's a skills directory, and as soon as you start it up, it will actually take over. Like if you wanted to contribute to SQLite, please do. You can clone the repo locally, fire up Claude or Codex, and it will actually take over. It'll be like, okay, what are we doing on this project? And I have full context, and it will help the first contributor. I want that to happen. Like, oh, you want to build something? Here's how we do it.
Yeah.
Oh, you have
Yeah.
a bug? Here's how you can report it.
Yeah.
Yeah,
No.
it does all the work for you. And that's,
Yeah.
I think, from an open source standpoint, having a contributor model that is friendly to that makes it so much easier. I want everyone on this call to be able to clone the repo and say, you know what? I wish it had, and not only create the issue so that it's all clean and create the spec, all that stuff, but also build it and submit a PR. And then the AI is but you're in the charge of doing that. And then I'll review the PR. If I don't like it, I'll reject it.
you
Yeah,
know,
isn't that an interesting thing? Because that's kind of like contributing financially to an open source project.
it
Like,
is exactly that.
yeah,
Yeah,
it's actually, I
you're
really like
donating your
that.
tokens. I
Yeah, it's
prefer
like,
your tokens.
yeah,
Yeah,
it's kind of like a different kind of open. I
it
suppose it
is.
is open, but you know what I mean? It's you're okay. I'm going to spend a couple of bucks making this
it's
feature and drop it in. That's a nice. I like
but
that.
it's more than that, Johnny. It's funding it, but also babysitting the agent. It's
Yeah.
a little bit of work.
Well, John Haddad was like he's using SQLite for some stuff, and he's like, you know what I needed to do is not just read SS tables. I wanted to read commit logs so I can get up to the second, up to the millisecond writes to the system. So I have a PR. He did it. He wrote the whole thing. He followed the procedure. There's a spec out there. There's a PR sitting in the PR queue that I got to review. But man, that's an awesome contribution. And he donated his tokens. Um, but I think that's a lot. There's a lot of anti AI and a lot of open source right now because like the Z project, for instance, like we will not even if you even say the word AI, you're done. That's extreme. I think the real benefit of that is like you get better contributions from more better contributions. The middle ground is where it sucks. Is like, and we've seen this on the Cassandra project. We've had people just bomb PRs in there. I had to go through and clean up like 400 PRs in the Cassandra
Wow.
project because somebody had set up an agent to go find every misspelling. And
Yeah.
so every misspelling that was in a comment in every source code file, like it was like this Java file is a misspelling in a comment. I'm like, that that took me a couple hours just to cut through of like, what is all this stuff? And of course, and then I had to tell this person, like, if you change the Java file, you have to run the tests, even though it's a comment, you know? So that's the downside of AI. So that's why I'm trying to think of like what's the better way to use AI to participate that isn't that.
Well, you can start having your Claude reviewing the PRs before you even look at them. That's
Well,
the
I'm baking it into the project. That's what
yeah.
I'm doing. Like I have the contributor model built in as part of the Claude and as a skill, so that instead of just dropping in there like a human was normally using it, you can just ask the AI, like, hey, I want to contribute something. What's the procedure?
Yeah, well, you can set up GitHub runners to actually start up Claude
Yeah.
and
Yeah.
actually do stuff with it as well. It does kind of help reduce the funnel down as well, and also having a look at issues, automatically triaging them, severity, putting feedback back, in not just that kind of static form that no one wants to fill out, but actually develop a conversation that's able to essentially work through whoever raised that issue to kind of, okay, give me more detail, more detail, more detail. Okay, that's just not true, kind of thing. It's I've seen a couple of projects. I think even Claude Code is doing that for all of its stuff. It has a whole bunch of agents just doing the complete management of all of that stuff
Oh
coming
yeah,
in. Yeah,
Claude is 90% written by
yeah,
itself,
yeah, yeah,
automated.
That's great.
Combination of GitHub Copilot, CodeRabbit, um, and Claude in code spaces. You can install Claude into the code spaces. Like you don't even have to go in there. But between these three, because GitHub Copilot has a lot of the models already, you don't have to use Claude, but CodeRabbit and GitHub Copilot, you can literally make an issue on the project, assign it to GitHub Copilot. It'll do a PR for you. And then CodeRabbit will do the PR review. And then Copilot will commit it. I mean, we're doing this for about a year now, right?
yeah.
So like telling people that this is the way it's been done for about a year now. People are like, what are you talking about? It's like nobody programs anymore.
Yeah.
We just make issues. We write specs and we make issues. Like AI is doing everything for us.
Brave new world.
Brave new world. Well, folks,
Yeah, we're
at
at way over time here. We still got people hanging out listening to us. Yeah.
This is but this is what happens on this Planet Cassandra call is that people are like, hey,
John Mill, you joined after the call was over. He's like, wait a minute, people are talking about AI. I was like, wait a minute. You're late. That's okay.
I do have to hop off, but I can make somebody a host if you guys want to continue.
No. My wife has given me evils now. I've got to finish.
way past the beer o'clock and the dinner o'clock.
But,
thank you.
Thank you, Rahul, and everyone for setting this all up and continuing to kind of look after this and herd all the cats. It's greatly appreciated.
Thank you also, Patrick. Appreciate it. And I'm going to ping you about getting CQL Lite on the calendar. And
all right, let's do it.
Look forward to it. Yeah.
All right, see ya.
Take it easy, everybody. Bye-bye.
Bye, everyone.
Thanks lots. Bye-bye.